Jai Hind everyone. This is Dr. Naresh Kumar from Ajay Kumar Garg Engineering College, Ghaziabad. Welcome to the lecture of Digital Data Communication Networks. So in this lecture, basically we will discuss the concept of multiple access for data communication. The contents for the lecture will be as discussed. Basically in this lecture we will discuss the multiple access protocols that can be used for data communication networks. Mainly in this lecture we will cover the random access, controlled access and the concept of channelization. So first of all, what is multiple access? Basically in communication system or in any other systems, sometimes there may be requirement that there may be a common or single resource and multiple users or multiple devices want to have access over that single resource. So we have to use that resource in a particular manner in some system so that there is no problem of contention. So in some cases we have single resource and this single resource is required by multiple devices. So if simultaneously all these devices request for this single source, there will be problem of contention. So that will result into the contention problem, or we will see that in data communication, let's say there is single channel or medium and two devices want to have access or simultaneously want to transmit data over that channel. So there will be collision of data. So we can say that there will be problem of contention, that is contention problem, or there may be collision. That is, in the case of multiple access, we solve this problem of contention or collision. That is, whenever there are multiple devices which want to have access over the single resource, there may be problem of contention or there may be data collision problem. To avoid that, we have to use the concept of multiple access, or we have to make some kind of mechanism, or we have to use some kind of techniques. These techniques are known as the multiple access techniques. That means in the case of data communication, there may be problem of contention or there may be data collision problem when we have multiple devices which want to have data transmission simultaneously over the single resource. So to avoid that or to solve that, we have to make some kind of mechanism. This mechanism is known as the multiple access, or we have to use multiple access techniques or multiple access protocols to ensure that there is no contention problem or there is no collision problem, or we have to avoid this problem. So basically, if we talk about the data communication, basically here we are talking about data communication. We know that in the data communication, the layered architecture is used or concept of layers is used. For example, in the OSI model, the data communication is explained using the 7 layers. So one of the layer in the OSI model is data link layer. Now, as per the IEEE, the functionality of data link layer can be divided into two parts, that is data link control and multiple access resolution. Data link control is basically responsible for, let's say, we know that it is responsible for framing, flow control and routing, etc. So these type of functions are performed by this data link control, whereas this multiple access resolution is responsible for solving the problem of, as discussed, problem of contention and as well as, or we can say that, the collision. So multiple access techniques or multiple access protocols are used here to solve the problem of contention or collision, that is collision of data. So we can say that the multiple access is ensured with the help of protocols. So these protocols are known as multiple access protocols. These can be categorized as random access, controlled access and channelization protocols. Further, there may be further types. For example, if we have to use random access protocols, then Aloha may be used, CSMA technique may be used, which have further two types, collision detection and collision avoidance. Now for the controlled access, we can use reservation technique or protocol, polling and token passing. Whereas in the channelization, we can use either FDMA, frequency division multiple access, or time division multiple access and code division multiple access. So as we have seen, the multiple access uses various protocols. Okay, these protocols have been divided into various categories. So first category is random access. For the multiple access, we have random access. Basically here we are, when we are talking about multiple access, means let's say there are multiple devices, okay, and for data sharing purpose these are connected with the single channel or medium. So this is the common channel or medium. So now all these devices want to have simultaneous access over this common resource, that is the channel or medium. Now to avoid the contention or collision, we have to use some kind of multiple access. So the first multiple access is basically random access. As clear from the name, in this case no station is superior. That means all these stations have equal priority. So randomly, whenever the data is available with any device, that will put that data or transmit that data over the channel. This is known as the random access. That means there are multiple devices connected with the common channel. So whenever the data is ready with the device, that will start transmitting, irrespective of whether the channel is busy or any other device is transmitting the data simultaneously also. So this is known as random access. Okay, so in this case, random access, the main technique or protocol used are Aloha, CSMA, and further CSMA can be CSMA CD, that is collision detection and collision avoidance. So in the random access, as we have seen, there may be two techniques. Let's say we are talking about Aloha. In the Aloha, there can be two techniques. One may be pure Aloha and another may be slotted Aloha. Basically in the random access, we have seen that the multiple devices or multiple stations may transmit data whenever they have data ready with them. Okay, so here we can see that station 1, station 2, station 3, station 4 all are transmitting data in a random manner. So here frame 1 is there, so from station 2, from station 3, station 4. So these are transmitting the frames in a random manner. Okay, and this is the collision duration where two frames are colliding with each other or data from different stations is colliding with each other. This is the case of pure aloha. That means data transmission is done at random time interval, not at the starting of a particular time slot. So that is ensured in the case of slotted aloha. That is, in the slotted aloha also the data is transmitted randomly, but only at the starting of a particular time interval. So whenever the particular time interval starts, only then the stations can transmit their data. So if we calculate the vulnerable time where there is possibility of collision of data, where data can collide with each other, so that vulnerable time we can see that it is double of the transmission time or single time period slot. So this is a case of pure aloha. So in the pure aloha we are seeing that the frame 1 is not ending there, the frame for the next station already started. Okay, so here also there is collision. So collision can be avoided when we have this time free, no transmission during this time, as well as no transmission during this time. That is, first frame is there, and if we have transmitted the new frame from here, there would have been no collision. So the vulnerable time here is 2 into frame time, which is very high. Now to reduce this vulnerable time in the aloha, we have another type of aloha that is known as the slotted aloha. In the slotted aloha, there are multiple stations. They may transmit their data randomly, but they will begin the transmission only at the starting of a particular time slot. In between the time slot, there is no transmission of data from the stations. So here we can see that station 1 transmitting the frame, next frame is being transmitted only at the starting of next slot, not in between, not starting from here. So new frame transmission from another user is allowed only at the starting of a particular time slot. So this is the case of slotted aloha. As we have seen the vulnerable time for the pure aloha, similarly for slotted aloha, as the frames can be transmitted only at the starting of a particular time slot. So here we can see that the vulnerable time is only equal to the frame time. So the time interval where the collision can have, that is reduced from 2 times frame time in the case of pure aloha, it get reduced to only frame time in the case of slotted aloha. Okay, so that's the advantage. Next is CSMA. It is also under the random access. So that is, CSMA stands for carrier sense multiple access. Carrier sense multiple access. This is also a random access technique, but the main difference is here, in the case of aloha, whenever the data is ready, it is directly transmitted over the channel. In the case of CSMA, before actual transmission, the station actually waits for some time, it senses the channel. It senses whether any signal is present in the channel or not, whether there is any possibility for the being collision. So it's try to either detect the collision or it tries to avoid the collision. So CSMA is, again, this is also a random access. but we can say that it is slightly improved technique as compared to Aloha. In this case, data is not directly transmitted. Here, before the transmission, the station may wait for some time, check whether the channel is free or not, or check that what is the possibility of collision or avoiding. So that is the possibility here. So here we can see that the collision can be detected during the entire frame propagation time. So even when station A has transmitted, that frame has not reached up to this point. Even at this point, the transmission is there will be collision. So we can say that vulnerable time in the case of CSMA is equal to propagation time. So in the case of CSMA, three persistence methods can be used. First is persistent method, where the station continuously sensing the channel or medium, whether the channel is idle or we can say free, or whether the channel is busy. So if the channel is continuously being checked, if it is busy, there is no transmission, and whenever it sees the channel is free or ideal, then the transmission will start. In the non-persistent method, first of all, again the channel will be checked whether the channel is idle or busy. If it is busy, the station will wait for some time, and whenever the channel becomes free, even that, then also it will also keep waiting for some time, so that in that time interval also, if there is any frame, so that the collision can be avoided. So first of all it will wait, whenever it is free, again then it will wait for some time. So this is the non-persistent method. Then the P-persistent method, here we will also continuously check whether the medium is free or not. Then after that, like this, again we will wait, but transmission will not be there for first time slot and then next time slot. Basically here, in addition to the previous method, we will check what is the probability of transmission being successful. That is, what will be the probability? It calculates the probability that if it transmits now, what is the possibility of collision. So to avoid that, it also waits for some time, and if whenever the probability is suitable for transmission, only then transmission will be done. So basically CSMA can be divided into two parts: CSMA CD, collision detection, and another type is CSMA CA, that is collision avoidance. Whenever it is possible to detect the collision, we will detect the collision, but in some cases it is very difficult to detect the collision. So in that case we try to avoid the collision. So this CSMA CD is generally used in the case of wired LAN or wired system, whereas CSMA CA is used in the case of wireless systems. For example, in the case of wireless LAN, because in the wired system, whenever there will be collision, we will have high energy over there. Okay, so in the case of wired system, it is very easy to detect this collision, but in the case of wireless, as the signal travels the distance, the energy or power of the signal continuously decreases. So the level cannot be so much high that it can be easily detected that whether it is a single signal or multiple signal. So in the case of wireless LAN, the CSMA is used. In the case of wired systems, we can use the CSMA CD technique. So this is the CSMA CA, collision avoidance. First of all, to avoid the collision, we continuously check whether the medium is free or not. sensing will be there. After that, even when the channel is find ideal, that the channel or medium is free, it will not transmit. It will wait for some time. This is known as the interframe spacing. This is known as the interframe spacing. Okay, so it will wait for some time. Now this time interval for the IFS can be controlled depending upon the priority. Whether the data is of high priority, we may have IFS of very small duration, and if data may not be of very high priority, in that case the IFS duration can be more also. After that, again it will wait for the contention window time period. To avoid the collision, it will again wait for the contention window time period. This contention window time period can be of one slot, maybe multiple slot. Basically depending upon the condition of the channel, whether the channel is busy, so there is high possibility that there may be collision. So to avoid that, the number of contention slots can be increased. So that may also be controlled by controlling the what is the number of attempt. According to attempts also we can control this size of contention window. Let's say one is trying for the first time, so the contention window size may be small. If one device want to have transmit data, is trying to let's say is attempting fourth time, that means if he has to attempt for the fourth time, that means the channel condition is very busy. So in that busy case, we will provide more number of time slots, or waiting time period for the contention window will be more. So whenever these three conditions are fulfilled, then the frame will be transmitted. So in this case, basically we try for the avoidance of collision as much as possible. Then we have controlled access. Controlled access means here there are multiple stations, and one station, before it actually transmit the data, it will consult with all other stations. When all stations are agreed, only then a particular station is authorized for transmission, and that particular station will transmit the data only when it has consulted all other stations that no one is transmitting. So in this case, this is known as the controlled access. Okay, so controlled access means in this case there can be multiple stations. Out of these multiple stations, we may make one station as the master or primary, while the others may be, or we can say that one may be the server, while the other stations may work as secondary or may work as the clients. So basically in the controlled access, the channel or medium is accessed by multiple stations in a controlled manner after consulting with each other. When they agrees, only after that a particular station will transmit the data, and that particular decision is made with the help of different techniques known as reservation, polling and token passing. So based upon these techniques, the controlled multiple access can be done in the case of data communication. This is one example, reservation access, as we do in the case of train reservation. So before actual transmission, a particular time slot is given to all the stations whether they want to transmit the data or not. So firstly there will be a reservation frame, and as there are multiple stations, station 1, 2, 3, 4, 5. So whichever station want to transmit the data, that will book the time slot or reservation will be done. So whichever station want to have transmit over the channel or want to have access over the channel, that will reserve its slot by putting 1 in this reservation slot, otherwise it will put 0. So from this we can see that station 1, station 3 and station 4 want to transmit the data. So during the reservation slot they will book the slot by putting 1 into that, and after that time slot will be allotted to these particular stations for transmission. Okay, so there is reservation and there is no chance of collision. Another technique that we can use is select and poll. As we have discussed, whenever there are multiple stations, one can be made primary while the other can be work as secondary or clients. So in the case of this technique, there may be two cases. First case can be where this primary want to send. Okay, so this primary want to send, so wherever this primary want to send the data, transmit to data, that will select that particular station for data transmission. After that, this selected station B, let's say this primary wants to transmit data to the B. So it has selected B. It will send the acknowledgement, yes, I am ready for the data. Then data will be transmitted by the primary to the secondary device, and then finally data acknowledgement will be sent by the receiver. Now there may be second case. Second case is basically where the A/B wants to send data to the primary. Okay, so in this case also the initiative or controlling will be done by this primary device. So basically it will poll all the stations. This primary station will send a poll command firstly to A, that you want to transmit data or not. So a polling command will be there. If A wants to transmit data, it will give the positive acknowledgement or data will transmitted, or if A does not want to transmit data, it will send a negative acknowledgement. So primary device send the poll command to the A device, you want to send the data or not, then the A responded with negative acknowledgement. So the communication terminated here. Again it polled to the device B whether you want to transmit data or not. So in reply to that, it directly transmitted the data. Yes, I have data for transmission and I am sending that. So one step short is there. So after that it will send the acknowledgement that I have received the data. So for controlled access we can use the select and poll technique also. Another technique that can be used for controlled access is token passing access. There can be a token system. Whenever a station has to transmit the data or high priority, a token is assigned to that particular system or device. So any system or device in the data communication network that has a token at that time will have high priority and that can only transmit the data. So if token is available with only one device or one system, only that device or system can access over the channel. So there will be no collision or no other station can transmit in that duration. So whenever the data has been transmitted by the one device, it will pass the token to the next, and then after transmission of that, the token will be passed to the next device. So in this way, the token passing system can also be used for controlled access data transmission. Basically, this is used mainly in the case of, we can see that in the case of ring topology, we are using this token passing system for controlled access. Next technique that can be used is channelization. Basically, in this multiple access, generally we share the channel. This channel can be shared among the multiple users. Multiple users or devices. So this channel or medium can be shared among multiple users based upon some parameter or technique. So that can be, for example, we may share this single channel with the multiple users on the basis of what? On the basis of, let's say, frequency. That is known as the FDMA, frequency division multiple access. Another technique that can be used for sharing the channel among multiple users is based upon time sharing, time basis. That is known as the TDMA. Another technique that can be used is on the basis of codes. That is known as the CDMA. Okay, so let's say we have a single channel. This single channel can be divided into multiple small slots. Okay, and each slot can be assigned to a particular user or multiple users. Okay, so the common channel has been divided based upon the frequency or small frequency slots, and each slot can be assigned to a particular user. So we are assessing the common channel based upon the frequency division. Another may be time sharing basis. We can use the entire frequency band by multiple users based upon the time sharing basis. Let's say during T1, one particular user is using the channel. At T2 slot, another user is using the channel. At T3 slot, another user is using the channel. So we are assessing the same common channel or entire bandwidth of the channel among the multiple users based upon time sharing. So users may be differentiated based upon the frequency, based upon time slot, and based upon the codes. Unique codes may be assigned to every user. That is the case of CDMA. So here we can see that in the case of FDMA, there are frequency slots, and each slot can be assigned to different user 1, user 2, user 3 and user 4. So all users are using the channel simultaneously based upon frequency slots. So frequency slots are assigned. Another technique can be time division. So bandwidth is assigned to the users based upon time slots. So during particular time interval T1, a user 1 will be there, user 2, the user 3, so different time slots are there. Okay. Another technique is CDMA for security purpose. This CDMA means for every user we may assign a unique code to every user, and this unique code can be created in the form of pseudo noise sequence, which can be generated with the help of shift registers. Okay, so every user is different from each other because they are using the different code, and one code is accessible only through the particular user only. So the same code needs to be used as the encoding side or at the decoding side. So if the message is received by any other user, as the code is different, so it will appear as a noise for that user. Okay, so there is, so same common channel is used by the different users on the basis of different codes, that is unique codes are assigned to every user. As unique code is required for encoding and decoding or for transmission and reception, so in the case of CDMA we ensure the security. So it is a highly secure system. So that's all for this lecture. Thank you everyone. Jai Hind.